Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello, welcome back to the show. I hope you're well. In today's episode, we're going to go into a little bit more detail about electron configuration and about atomic orbitals. If you haven't already listened to the previous episode where I introduced and defined the basic rules around atomic orbitals, then I would suggest pause this episode and listen to that one first, because this one will make a lot more sense once you've heard the previous episode. Okay, what are we going to talk about today? We're going to talk about electron configuration. What does that mean? And we're going to talk about how and why electrons fill the orbitals and shells in the way that they do, and in the order that they do as well. We'll also discuss the notation we use to describe that electron configuration. Okay, so what is electron configuration? Well, it's the arrangement of electrons within an atom. It's which orbitals in which shells those electrons exist in. And we can apply it to simple ions as well. And when we do this, we consider the atom or the ion in its ground state. In other words, it hasn't got any electrons with additional energy excited to higher energy levels than their base level. So electrons will go into the lowest available energy orbitals. The lowest energy orbitals are in shell 1. Next lowest are those in shell 2. But the s orbitals and p orbitals have different energy levels to each other. We'll talk about that. The next are in shell 3. Again, the s, p and d orbitals have different energy levels from each other, and so on. So if an atom or ion has one electron, that will go into the first shell in the s orbital, and we call that the 1s orbital. If it has two electrons, that second electron also has to go into the first shell. There is only that extra space in the s orbital, so that second electron also goes into the 1s orbital. And as you'll remember from the previous episode, those two electrons in that orbital, or any orbital, have to have opposite spin to each other. One has spin up and one has spin down. And that is the same for all orbitals. Okay, so for an atom or an ion that has 3 electrons, the first 2 electrons will be in the 1s orbital, but the third electron can't fit into the first level. There is only accommodation for 2 electrons in that first shell. So that must go into the second shell, and it has to go into the lowest energy orbital. Well, the s orbital is slightly lower energy than the p orbitals. So that electron, that third electron, will be in the 2s orbital. The next electron also goes into 2s because that again is the lowest energy orbital available. But for an atom or ion with 5 electrons, that fifth electron can't go into 1s or 2s, they're all full. The next lowest energy is the 2p orbitals. So it goes into one of the 2p orbitals. And this is where we need to understand a bit of detail, because something we really get asked about is what happens to the subsequent electrons after that. So, okay, let's consider an atom or ion with 6 electrons. We already know that 1s is full and 2s is full, so that's 4 electrons in the 1s and the 2s. And the 5th and the 6th electrons both go into the 2p orbitals. Now, you'll remember from last week's episode, there are 3 of those orbitals. They're equal in energy to each other. So what happens to that 6th electron? Does it go into one of the empty 2p orbitals, or does it go into the one that already has an electron in it? There's a rule about this. All the orbitals within what we call a subshell, so those 3 2p orbitals are the 2p subshell. All the orbitals have to be half filled before any doubling up, before any of the orbitals gets a second electron to pair up with the first. And that is because there's a slightly higher energy requirement to double up within an orbital, because of course there's a little bit of repulsion between the 2 electrons. They're both negatively charged. As we continue to add electrons and build up the size of an atom, and enough electrons to go into the d subshells, the d orbitals. So the same applies again. All 5 of those d orbitals must have a single electron in each before an electron can pair up with another in one of those half-full orbitals. this point, we need to talk about a little bit of a rule that you will need to remember, because you'll be asked about all of this, but you'll be definitely asked about what I'm about to talk about. So far, we've talked about the fact that we fill 1s, then 2s, then the 2p orbitals, and then 3s, and then 3p are next. And logic says, based on what we've talked about already, that the next electrons would go into the 3d orbitals. And actually, the 4s orbital has slightly lower energy, so the 4s orbital fills before 3d. And that is why, when you look at the periodic table, you'll see that the second and third periods both have 8 elements. It's only when we get to the fourth period and have filled the 4s that we start to fill the 3d. And that's where you see the beginning of the transition elements. Watch out for that one. It's a favourite thing to be asked about in exams, in homeworks, and in your assignments too. And the last thing I was going to talk about today was the notation, the way that we write down the electron configuration in shorthand, because what we've talked about in words would fill up a lot of page if we were going to write that down. So firstly, let's consider how we write that. And we'll use the example of hydrogen first. Hydrogen has 1 electron, and as we mentioned earlier, that will go into the 1s orbital. So to note that, we would write 1s1, and that second one is a superscript after the s. Helium has 2 electrons, both go into that 1s orbital as well. So the electron configuration is 1s2. In this case, the 2 is a superscript. Let's think about carbon with its 6 electrons. It has 2 in the 1s, 2 in the 2s orbitals, and 2 in the 2p orbitals as well. So we would write that as 1s2, 2s2, 2p2. The final 2 out of each of those sections is a superscript. And note how we always start with the 1s and write the electron configuration in order of the energy level of the orbitals. You will find more detail on this in a PDF that I've written, which you can get by visiting chemistrymadesimple.net/orbital, and I will put that into the show notes. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistrymadesimple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself, and goodbye.